In today's video, we'll be talking about the Higgs boson.
But what is that, bro?
Chill, man. Let me get my intro done. We'll be seeing the Higgs boson, the Standard Model, and the Higgs field. So let's get right into the video. I'm pretty sure that when you put yourself on top of an electronic balance, you get a measurement in kilograms. But why? Why do particles and things have mass? It's all because of the Higgs field and how particles interact with it. Take a photon, for example. This particle right here can travel 152.1 million kilometers in only 8 minutes and 20 seconds. But why? It's all because of how the photon interacts with the Higgs field.
Imagine this guy right here is the photon. It's a normal guy in a party going to get a drink. He's not going to be stopped by anyone because no one knows him. So it's going to be very easy for him to get to the bar. And it's going to be relatively quick compared to other people. Like if we get Michael Jordan, for example. So if we get Michael Jordan right here, the GOAT, it's going to take much longer for him to get to the bar because everyone's going to stop him since he's the GOAT. So now that we know this, a particle gains its mass due to the interaction that it has with the Higgs field.
So in the previous analogy, the people in the room were representing the Higgs field, and the person going to get the drink was representing a particle. The first person could perfectly be a photon, so they have no interaction whatsoever with the people around them or the Higgs field, so they are massless. We call these particles massless, and due to this, the photons can go at the speed of light. Since Michael Jordan was being stopped by a lot of people, it meant that he was having a lot of interactions with the Higgs field. So he would have a bigger mass. Now that we know the basics, let's focus on the Higgs particle, or the God particle. But before zooming in, let's do a quick explanation of why it's called the God particle. It's called the God particle because Nobel physicist Leo Lederman originally wanted to call it the goddamn particle because it was so frustratingly difficult to detect. So when Leo Lederman was writing his book, the publisher thought that God particle would sell more books, so he stuck to it. Now that we know that little fact, let's get right into what the Higgs particle really is.
So in this animation that we can see here, made by the CERN in Switzerland, we can see a lot of particles moving at the speed of light. However, as they interact with the Higgs field, they slow down. As seen here, you can see them slow down, like Michael Jordan in the previous analogy. Now we have two protons colliding at very high speeds, which create a Higgs boson, which will decay very quickly. And due to this decay in the particle accelerator, scientists can infer that there is indeed a Higgs field.
As you've seen in the previous animation, when the Higgs particle decays, it looks like a splash. So this splash can be like a water splash in an invisible ocean, meaning that if scientists could find this splash, they could determine that an invisible ocean, in this case the Higgs field, would actually exist. We've got one last thing to cover, and that's the Standard Model.
The Standard Model is the best theory of the tiny building blocks of the universe. Particles like electrons and quarks and the forces that act on them. But one big mystery remained. Why do these particles have mass? And the answer came in 2012 when scientists discovered the Higgs boson, the particle that proves an invisible field that gives mass to everything we see.
I hope you guys enjoyed the video about the Higgs boson, the Higgs field, and the Standard Model. And I'll see you all in the next one. Peace out.